first of all, I would like to tell us about what you do at MainAd. What's your role, and what does the company do for a business?
I'll first of all tell you what is MainAd, right? MainAd is an online advertisement company, international actually. What we do is that we in simple sentence, we do online branding for our customers by doing a programmatic solutions with machine learning and in-house algorithms. So we were founded in 2007 by three founders from Italy itself, Pescara. And now we have our footprint in 50 plus countries and 8 offices global wise. And I am CTO of this company, and I am settled in India, Toronto.
Okay, that's great. So you started way before the cloud became the new normal. And so may I ask you why you decided to move to the Google Cloud platform and why serverless?
So before cloud and everything, we are still international at that particular time also. So we have to be strategically placed our servers in different locations global wise, and we have to need something like centralized database. So it's a nightmare for right now. It's a nightmare for a person like me, because I need like IT network supports like 40 people global wise, and I have to be there for them for 24/7. So when it cloud comes, and first of all we move to different kind of cloud providers first, then do the same stuff. Then we move to cloud Google. It becomes so easy to handle everything. So we were able to have centralized support team. First of all, that actually reduces less than 25% of people are actually bad for the people, but for the coming years, we have less support needed, less support. And why we move is that it's super, for me it's very super easy. So first of all, whenever we roll up something new out there and we create an automatic reporting systems, and every time something goes wrong, I get a message and it been saying that something goes wrong. So I just have to call the people. That was amazing. I can sleep night.
And that's a pretty good shift. So if you had to summarize the main advantages, the main advantages of your move, how would you describe them?
Well, first of all, thing that comes to your mind is cost. Of course, I already told the cost of having everything reported based upon usage base is good, and using serverless means that we don't have to have the resources ready for future actions. So it's always wind up its requirements as soon as it needed. So instead of having 4 core servers, it don't necessarily. If one core is more needed, it will automatically have only 1 core, not too much core. That's something that comes first to mind. Of course, as I told, the network support is something very good. And second thing that I really need is the performance. So ours is more like a big data kind of company. We have to handle a huge amount of data every second. So we have to be ready for that. And when I say that performance, it's not for I cannot perform within 5 minutes or 6 minutes. For me, it's like milliseconds kind of stuff.
Real time,
yes. So I was scared at the beginning, but as I see is that within few seconds, everything is from A to Z, and I have everything for me at the point. So performance-wise and serverless is very good for us. And the third thing is the availability of the serverless systems around the global platforms. So basically, it's available on possibly all data centers, plus or minus one. Most of the big data centers has all the serverless systems, and for us it's very important that our users and our servers to be very close to perform. That's it. I mean, there is load, but.
Very cool. So since you mentioned real time, could you describe a little bit more of the pipeline? What kind of processing do you actually perform on the real time data?
Sure. Well, if it's possible, we can show this.
Yep. I think I have to move mine so we have a little reference.
Yeah. So it's just a very shortcut of what we do, like to say that. So we have our compute engines and app engines that actually act like the first level of data collectors. So basically the PubSub is our queuing system. So basically we send around 50,000 requests per second to the PubSub. So most of the write happening to our system goes through the PubSub. We don't write directly. We don't have the time. So we send so basically every given time it's 5,000 requests per second. And as soon as the PubSub reads it, our compute engines, our data flows, auto-scaling stuff, so it will start to read this one, do some sort of aggregations, preliminary data analysis is going on there, and it moves the data to our storage devices. So we use Bigtable, BigQuery, Dataflow, MySQL, Cloud SQL for storing purposes. And finally, these data are also passed to our machine learning systems and as well as our data lab for analysis of the data. So in our architecture, Bigtable and Cloud Store act as our front-end data provider, and Bigtable Bigtable with the data lab act as the analysis data providers. Why is it like that? Bigtable is the fastest data response time that I have seen around this one. So I get data within 6 to 10 milliseconds. Mostly, maximum it goes to 25 milliseconds to respond from petabyte of data.
That's pretty fast. So how do you exactly route the request to the closest server? Because you mentioned that the server must be very close to the bidding server and the ADX server. So how do you manage routing all these requests per second to the closest region and point?
So generally as I told you, so I have servers everywhere, the data center that Google can provide in general. So we use the HTTP load balancer of the Google. The good thing of the HTTP load balancer is that if you have a traffic from US and you have an instance in US, it will automatically redirect to that server itself without we controlling anything, unless there is some reasons why it has to divert to the other one. Otherwise, it will send to them. So, I mean, compared to the past, this is a good thing for me. Like it's just change. I'm pretty sure that my traffic will be served very fast and with the most possible nearest servers that is possible. So.
That's great. So you mentioned the past. So can I ask you what your stack looked like before moving to GCP? So your technology stack, it was different. So how did it work before? And what was the hardest part of the migration?
Well, the older stack I little bit explained before, but the older stack looks more like we have cloud providers from different locations that we actually having this thing from US and everybody like that. And we used in Europe itself we used a dedicated servers as a backend service providers, huge 32 core servers like. In group has a database providers, and we use the communications coming from these servers going to this one because we have to do a big data analysis. So we need a centralized database to do this, so as before, responding within millisecond is impossible stuff for us to do anything. So that was fast. So the question was how easy was it to move to GCP?
Yeah.
So
So how long it took, for example, or what?
Generally, no time. In general, it's no time. First of all, when we tested started, it's only computer genes and we just testing. Then, like an explosion, everything moved to the GCP right away. So it wasn't very hard to move to the GCP. Just to understand the big table concept was something that at the start something is a problem. But I have to tell that the Google support we got, it was very great. I mean, almost perfect. Why I said almost perfect is that if they coded for me, that will be the last one. So I mean, we got support from Milan office, of course. We got support from UK office, US office on different areas. So because they were there for us, like on the core issues for us to solve this one. So I didn't feel the pressure at all of the moving.
That's interesting. So today we are seeing, startups or building from scratch, but there are also companies that need to migrate an existing product, and that's a real problem as well. And this sounds like a successful migration. Cool. So you have this experience, and what would you suggest to the community, or to what did you learn, and do you have any best practice or tips that you can share?
I would say that performance is your point. Big table is the best I see. So I already told that. So if you want to have very good performance on the thing, big table is more like a Redis cache, but in a storage point of view. That's the best thing that you can. For analysis purpose, BigQuery is the best. You can do actually similar like a MySQL or SQL querying. You can do the querying and everything like with petabyte of data. So for analysis purpose, it is the best that I've seen. And for cost saving kind of things, they also have things like partitioning, which allows us to not to call too much data, unwanted data to call the things. So that's it. I guess there are lot of things for me. It's about data. So how to handle a huge amount of data within milliseconds is what I am good at and what I need.
That's a real challenge. Okay, thank you for sharing your experience. And if anybody has questions, we are running a bit late, but Anoop will be around for another hour, maybe. Okay, so you need to go back. Okay, thank you again, Anoop.